So in our last class, we started discussing about indexing, because we need indexing for organizing documents that are collected from author's world or producer's world, so as to speed up searching, such that we have to find a mechanism of organizing our documents through indexing. There are different indexing structures available that can help us to well organize documents and then make them available for searching. For that, we already saw also the need for text operation and document pre-processing to identify as per the unit of the communication internally for the IR system words that are describing the content. Words that are describing the content are content-bearing words. By applying tokenization, stop-word detection, normalization, stemming, finally we come up with some of the words, obviously a compressed words that are representing a given document. We are not using the whole words that are available in the document, because some of the words are common words. Again, some of the words are similar with other word. Maybe it is a word variant, or it may be differing through superficial difference, either by using capital letter, small letter, or a combination of them, or character variant, like in Amharic. So such things are tried to correct, and then finally we have a dictionary words that are distinct. We don't use multiple words for indexing, but that depends on, again, the indexing structure that we select. Some indexing structures are trying to list out all the words that are identified. All the words means all the index terms. All index terms means for us vocabulary words available in the document collection that we have an access and able to organize them and make them ready for searching. We have different criteria already we set for identifying the indexing structure. We know in any algorithmic selection, data structure, file structure selection, we have to take into account running time and space utilization. We need an algorithm or data structure that makes our system fast and also takes less memory space. Here also, in identifying the indexing structure, we have to see the running time of that indexing structure in terms of indexing time, in terms of searching time, in terms of update time. And also we have to see to what extent it can optimize the memory space required for keeping the index file. Then what kind of access types are supported? Is that possible to access multiple words for checking the document at the same time or not? We prefer those indexing structure allowing us to access at the same time multiple records. So based on that, many index files are designed in the form of indexing structure for organizing document. The earlier one is the first one, which is introduced as an indexing structure, is sequential file. Sequential file, the name itself is sequentially keeping the index terms in our index file. So when we are keeping sequentially the index terms in the index file, we are arranging them following the alphabetical or lexicographic order, such that they are in sorted order. That one is one of the advantage in sequential file or in any indexing structure. They are keeping in sorted order. But in the case of sequential file, you may get multiple words that are available in a given document or multiple documents. Why it is keeping multiple words, even if they are available in a given document or in multiple documents? Because there is no way of keeping frequencies that are related to every word. As we said last time, we have term frequency, document frequency, collection frequency. At least keeping the term frequency and the document frequency will optimize the number of terms, index terms that we are keeping in our indexing file. Term frequency tries to calculate the occurrence of the given term in a given document. As a result, if a given index term appears multiple times in a given document, since we are capturing the term frequency of that given index term, we are only keeping one time that term with its term frequency. Then we can list out all the documents that are containing that term. In addition, having document frequency means we are trying to calculate the number of documents containing that given term. As a result, again, even if the index term is available in multiple documents, we are not keeping the index term as per the multiple documents it appears in. So we keep only one index term along with its document frequency, term frequency, collection frequency. So based on the document frequency, collection frequency, term frequency, we can see the extent to which a given term is available in one document and also across the document collections that we have. Since such flavors are not there within the sequential file, we have to keep all the terms that are extracted from the document collection. If a given term appears in one document multiple times, it has to be kept is equal to term frequency, the number of times it appears in that given document. Also, if the document is available across the document collection multiple times, again we have to keep that terms along with the documents that contain that term. But one of the advantages is the terms are sequentially ordered, following the alphabetic ordering A to Z. We are comparing starting from A, B, C, then until we reach to whatever query that we have. But actually, even if it is simple, easy to construct sequential file indexing for indexing purpose, but it doesn't fulfill like optimizing running time, optimizing updating time, optimizing memory space requirement. But as a first step towards coming up with the index file to organize our index terms, historically we'll try to discuss it. In fact, if you have only short or few documents, still it works. But since nowadays we are dealing with large collection of documents, it's better to go for another indexing file rather than sequential file. How it works? Like given two documents, last time we tried to see what are the terms that we get, because given document collection, the first step is we have to identify words. using tokenization. So when we are trying to tokenize, we have to identify word separator. Can we use space only, or semicolon, dots, brackets, quotation marks? Many non-alphabets are there as a special character. So when you tokenize as a word separator, we have to bring those different special characters used for taking into account basically the grammatical rule of the language. So in the first document, for instance, we can use space, semicolon, and a dot. Again, in the second case also, spaces are there, dots are there. So we have to create a generic special character remover. That one is easy in Python. Then in addition to space, we have to remove the special characters. At the end of the day, we'll get a list of words or bag of words. But all words, as we said earlier, are not equally important for representing a given document. Which words are more important if the word is describing the content of the document? So it's better to ignore common words or stop words like articles, like pronouns, like adjectives, like adverbs, like conjunctives. So in our case, we have to ignore I, D, was, the, so, let, it, be, with. So in general, those words which have minimal discriminatory power, one document from another document. If they are the same in any document, if their meaning is similar in any document, if they don't have any capability to tell us the content of a given document as compared to another document, even if they are coming from different disciplines, still if the meaning is the same, we don't need them. Because at the end of the day, they are creating noises for the information retrieval system. By creating noises, they are reducing the efficiency, effectiveness of the system. Running time is increased. Effectiveness in the retrieval of relevant documents also affected. As a result, it's better to go for ignoring common words, stop words. Also, there may be superficial difference among words. Some words may be written in capital letter, some words may be written in small letter, some words may be written a combination of them. So it's better to normalize again. So all the words that are in capital letter or a mix of capital letter used with small letter, we have to use to lower, and then all the words should be written in small letter. Again, we have to apply stemming because there may be words that are varying because of an addition of suffix, prefix, infix, or circumfix. So whatever is appearing as the beginning, as the end, as an extra character to a given base word, we have to ignore it. Like in this case, there is killed, K-I-L-L-E-D. E-D is to mention past tense. So it's better to remove ED than take KILL. Also, ambitious. The base word is ambition. If we are unable to come up with ambition, at least we have to remove IOUS and take AMBIT to bring it to the base word or stem word. Finally, after applying the pre-processing linguistics techniques, so the linguistics process will minimize as much words that are confusing our information retrieval to go from one document to another document in search for relevant document. So then finally we'll get dictionary words. Words that are describing and also with a single meaning. But as I said, the problem of sequential file is, even if it is keeping in sorted order, starting from A, B, C up to Z, since it doesn't capture term frequency, document frequency, collection frequency, you may get multiple words within the sequential file that comes from a given document or multiple documents. In our case, Brutus is appearing 2 times because it is available in document 1 and the document 2. Also, kill is available in one document only, but it appears multiple times. So then we have to have kill 2 times with where it appears document 1, kill, document 1 again, kill. But anyway, since it is in sorted order, we can find a data structure called binary search on top of this that can search logarithmically. But the problem is, even if it is easy to construct, even if it's simple to construct, when we are dealing with sequential file, especially updation is very tough, very complex, because rather than incrementally indexing, such sequential files can be updated by re-indexing, because we are keeping multiple times the term. If there is a term called kill, again comes. If it is coming from another document, we have to move 1 or 2 steps depending on the number of KILL we get. And then we have to insert them in behind. You may get ambition multiple times or Julius multiple times. So we have to, on the one hand, clear some space by moving words to another space. So such shifting of words by itself is taking time. Again, inserting in their proper place the new words again takes time. As a result, it's almost like a re-indexing sequential file is working. So we are ignoring the previous index file and we are trying to reconstruct again a new indexing file. But as a first step, we appreciate, based on the problem of sequential file, weakness of sequential file, challenges of sequential file during indexing and the searching, many other indexing mechanisms are recommended by scholars. One of the well-known one is inverted file. Inverted file, the name itself is inverted, means documents are kept using the words they contain, such that given a word, it's trying to identify all the documents that are containing that word. So we are accessing to documents through the word they contain. That's why it's called inverted. But the advantage of inverted is, on the one hand, it's trying to organize the documents based on terms. So it's fitting to the language of their system, word level. Also, inverted file can capture frequency-related information. Term frequency, document frequency, collection frequency. Even in addition to frequency, it also has a mechanism of keeping the location of every word, the position of every word in the given document. as we are keeping the position location of words, we can view for the users where that word is appearing in the document by bolding, by coloring, such that users can have a better feeling. As we have our words are within the document, we have an assumption that the document is relevant for our query. So more satisfactions are there with the users. In addition, by keeping the frequency related information, the advantages, we are not keeping multiple times terms along with the document containing them. Having term frequency means we are keeping only one time the word which is appearing multiple times in a given document. Why we need document frequency? It also solves the problem of keeping multiple times terms that are appearing in multiple documents. Of course, having frequency related information has basic advantage of trying to identify the extent to which a given term is important for representing a given document. So frequency related informations are optimizing to know which terms are more important for representing which document. Even if two terms are already available in different documents, but their representation importance may be different. Such things can be identified based on frequency related information. As I said last time, as more documents are containing a given term, that means if the document frequency is high, the term is less important for representing that document. If the term frequency of a given term in a given document is high, that term is very important for representing that given document. So we can judge using their frequency which term is important for representing which document. So having frequency related information helps us therefore to judge the importance of the term for representing a given document. Accordingly, we can even sort as per their importance in representing a given document. So that one is important still for searching purpose, because when we are searching, we are trying to find the similarity between a given document against the given query. So as it contains more important terms that are related to query terms, that document becomes more similar with the query term. As the document is containing less important terms that are not similar with the query, that document is penalized and becoming irrelevant for that given query. So still the similarity measurement is more precise, near to identifying relevant document for a given query, unless and otherwise the meaning is different as compared to query, then terms can simplify the way we are searching for relevant documents for a given query. So in Retrieval, on the one hand, they are keeping only vocabulary terms without repeating a given term multiple times, like sequential find. In addition, they are also keeping the frequency related information, which is critical to identify which term is more important for which document. Also, location related informations are kept. As a result, more informations are provided in inverted file that are critical for searching and for displaying relevant document for the users. And even our memory space requirement is optimized, since only vocabulary terms are kept. Also, searching is optimized because we are keeping just the vocabulary terms. So keeping the vocabulary terms has an advantage of what? An advantage of optimizing searching time, optimizing indexing time, optimizing memory space requirement for creating the inverted file. Having location related information, again, on the one hand, we can easily make the users feel that their queries are taken into consideration in identifying the relevant document for their query, because knowing the location of